In this section, we'll be dealing with geometric sequences. What is a geometric sequence? A geometric sequence is a sequence of numbers where the ratio between one number and the next is always the same. Or in other words, to get to the next number, you always multiply by the same amount. For example, 3, 6, 12, 24, 48, 96. This is a geometric sequence because you are always doubling. Each number is twice the previous. To go from 3 to 6, you multiply by 2. To go from 6 to 12, you multiply by 2. From 12 to 24, you multiply by 2, and so on. Or for example, 2, 10, 50, 250, 1250. This is also a geometric sequence because each number is 5 times the previous. To go from 2 to 10, you multiply by 5. From 10 to 50, you multiply by 5. From 50 to 250, you multiply by 5, and so on. So there's a key fact to remember about geometric sequences. A geometric sequence increases much more rapidly than an arithmetic sequence. So here's an example of arithmetic sequence. An arithmetic sequence, if you remember, is one where from each number to the next you're always adding the same amount. So let's say you start with 1 red square. In an arithmetic sequence, if the next term is 2 red squares, that means you're increasing by 1 red square each time. So the term after that is going to be 3 red squares, then 4 squares, 5 squares, and so on. Because we're always increasing just by 1 square each time. But in a geometric sequence, if we also start with 1 square and then go to 2 squares in the next step, we're now doubling. So the third term in the sequence is going to be 4 squares because we're doubling from 2 squares to 4 squares. The fourth term is going to be 8 squares. Once again, we're doubling. The fifth term is going to be 16 squares. The seventh term is going to be, or the sixth term is already going to be 32, which is far bigger than this screen. So in a geometric sequence increases much more rapidly than an arithmetic sequence. For example, in a certain sequence of numbers, each successive number is 3 times the number that came right before it. If the difference of the fifth and first terms is 10, what is the first number? When dealing with a geometric sequence, just like as when you're dealing with an arithmetic sequence, you can set up a variable as your first term and then write each term in terms of that variable. What does that mean? Well, suppose that x is the first term in our sequence, because we don't know what the first term is. We'll just call it x. Now we know that each successive number is 3 times the number that came right before it. So the second term is going to be 3 times x. The third term is going to be 9x because that's 3 times 3x. So to go from 3x to 9x, you multiply by 3. So the fourth term is going to be 3 times this. Each term is 3 times the one that came before it. So the fourth term is 27x. The fifth term is 3 times this, or 81x. Now we know that the difference of the fifth and first terms is 10, so we'll write that as 81x minus x equals 10. 80x equals 10, because that's what 81x minus x equals. And when you divide both sides by 80, you get x equals 10 over 80, or x equals 1/8. Therefore, the first number, since that's what the question is, the first number is 1/8, because x is equal to the first number. That was the variable we set up for the first number. Or for example, suppose that a gambler in a casino doubles his bet every time he loses. If he started with a $100 bet, how many times would he need to lose in a row before he placed the bet worth approximately $3,000? So if you're doubling down every time you lose. Well, if you start with a $100 bet and then you lose, you're going to put down a $200 bet. So that's after your first loss, you're putting down 200. Because this is also geometric sequence if you think about it. You're always going from one term to the next and you're multiplying by 2. So if he loses again, he's going to double down and now put down a $400 bet. If he loses a third time, he's going to put down an $800 bet. If he loses a fourth time, he's going to put down a $1,600 bet or a $1,600 bet. And finally, if he loses a fifth time, he's going to put down a $3,200 bet, which is approximately $3,000. So the answer is 5 times. This person needs to lose 5 times. Not bet 5 times. He's betting 6 times, but he's losing 5 times. To go from one to the next, you need a loss. So this is 1 loss, 2 losses, 3 losses, 4 losses, finally a 5th loss when he places this bet. So the answer is 5 times. He needs to lose 5 times before he bets approximately $3,000. Let's take a look at this last one. We're told that the number of roaches in a house triples every 4 weeks. If there were 100 roaches to begin with, how many will there be at the end of exactly 1 year? Assume there are 52 weeks in this year. What we'll do is we'll make a chart for roaches and weeks. So at the beginning, in week 0, before we start counting, there are 100 roaches. Now, we know that the number of roaches in a house triples every 4 weeks. So after 4 weeks is going to be 100 times 3 roaches. After 8 weeks, so another 4 weeks later, is going to be 100 times 3 squared. So here, it's important to realize that you can write a lot of these geometric sequences using exponents, because otherwise the numbers start getting too large. When we go from 100 to 100 times 3, we're just multiplying by 3. When we go from 100 times 3 to 100 times 3 squared, once again we're just multiplying by 3. So after another 4 weeks later, at the end of week 12, is going to be 100 times 3 cubed roaches. Once again, just 3 times the roaches that were before. So the question is, how many roaches are there going to be after 52 weeks? Well, one way to think about this is that 4 is equal to 4 times 1. And 100 times 3 is the same as 100 times 3 to the first. 8 is equal to 4 times 2. And here, this is the number of roaches is 100 times 3 squared. Hopefully you start seeing the pattern. So at the end of week 12, which is 4 times 3, is 100 times 3 cubed roaches. So at the end of week 52, which is 4 times 13, there should be 100 times 3 to the 13th roaches. And that is the answer. If the number of roaches in the house triples every 4 weeks, and there were 100 roaches to begin with at the end of 52 weeks, there's going to be 100 times 3 to the 13th number of roaches, because the number of roaches is going to triple 13 times.